Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
How does the water level prove that there's no drop from horizontal?
Because it's an even altitude, right? The water levels it out itself. There's no drop. So if you take that as a fact, right, there's no drop, then you say the horizontal has to rise.
So that's your assumption is that that the water level creates a horizontal that is parallel to the surface of the earth, right?
No, it's not an assumption, right? It's just a fact that the water level does that, right?
To you, it's a fact.
But the numbers, right? To the numbers that they've give us, the ballers, right? These are drop from horizontal, right? So these are the numbers of the water level dropping from horizontal.
Okay.
But like I say, it doesn't drop because that's what you call flowing water, right? So what you have to do is you have to then go and look at the other model, the hump model, right? But the hump occurs at double the distance. So you then have to pretend there's a chord, right, from one end to the other. And the sagittar, now the hump bit, now becomes what was the drop. So if you have 400 meters of water level, then there should be a 3.1 millimeter hump that would be measurable there, right, within the numbers that they've given us.
Have you measured that 3.1 millimeter or the lack of the 3.1 millimeter in the center of a 400 meter water level? And if so, have you measured that?
No.
No, you haven't. You haven't measured it. You haven't measured that there isn't, or you haven't measured that there is.
Right. Do you get the idea that there should be something there, mate? You're agreeing that there is,
of course,
something. Okay, right. Okay. So as long as you say that there is a chance that there is something there, right? We can measure the water level at that distance, can't we?
We what? We can't?
Right? We can measure the water level at that distance. Providing you've got a water level that's 400 meters long, you can measure the level anywhere along that point from the beginning to the end.
Sure. You can take your water level from point A, walk away from point A, all the way out to 400 meters, and you'll be the same altitude above, the surface, above the water as you are at point A, right?
It would just be the same altitude, an even altitude.
Even altitude all the way across.
Yeah. Now, you could use geometry to use that as two different points, like you do with a straight line, to prove that two straight lines cannot share a common segment. Or you could choose to prove that two lines are parallel.
Got it. But I get the one straight line. So from A to B, the measure on the water level from water level A to B, that's a straight line. Now, how do you confirm that is parallel with the surface of the water?
It is the water level.
It's its own.
No.
Yeah, the water level is the water level.
No, the level of the water underneath. The surface of the water.
The water level doesn't care about what's underneath it, Brandon.
I understand how the water level works. So it'll give you an even altitude out to 400 meters. So you're at point A, 400 meters away, you're at point B. Let's say you're 3 feet above the ground with your water level.
Yeah, and we've also got steps at every 100 meters along the way.
That's fine. So if you drew a straight line, an imaginary straight line from point A, 3 feet above the ground to point B, 400 meters away, 3 feet above the ground, that would be a straight line. How do you confirm that line is an even altitude all along the 400 meters above the surface of the water?
You use geometry to prove it.
Okay, how do you do that?
Can I jump in?
Hold on no. Okay. How do you do that?
I was going to help you. I was going to answer your question, but okay.
Oh, okay. If you got the answer, sure.
Well, it's not. I'm saying I don't have the answer, but I kind of hear you guys talking past each other, and you're not on the same frequency. So, let me ask you this question real quick, Brandon. Why are you asking Bev the question you are?
Because he made the statement that we could. Well, I don't know. I'm trying to understand where he's coming from. If he has proven that somehow the shape of the surface. Surface of water is flat, is a straight line. I want to know that. And that's the part I don't understand, is how this experiment proves that.
Okay, so this is the way I would answer it if you were asking me this question. I would say this. When you've got your water level, you mark off on each of the containers at the ends. Like if you hold them in front of you and they level out, you mark that off. Then it doesn't matter what the terrain is. You go up and down, zigzag over rocks, under this, blah, 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 and you're 500 yards apart. That you will know that those two ends are level because you marked off what level is with that amount of volume of water. So that if you get to 500 yards away and you say to yourself, I'm going to trick Bev right now. I'm going to raise up my end and throw off the level. He's going to see it.
Yeah.
That's how you
go ahead.
That's how you know they're level.
I understand.
You don't need anything else.
I understand that the 2 points are level with each other. I understand that they're the same altitude and connecting them.
Let me correct you.
Creates
It's
a straight
not an
line.
altitude. It's elevation. Sorry, I'm just being pedantic. It's elevation.
No, it's an altitude. The water level in the tube isn't on elevation. It's not on the ground. It's above the ground.
Okay. All right. That's fine.
So they're at the same altitude. They're 3 feet. We've got a straight line from A to B. How do I know that the surface of the water is also a straight line? Then all along that imaginary line, at any points along that imaginary line is 3 feet above the surface of the water. That's what I want. How do I know that?
What water are you talking about now?
Travis, why don't you let Bev field this one?
Because Bev's not asking the question that I think Brandon is getting at. That's what I said at the beginning. I feel like they're talking.
Brandon's asking the question.
Okay, listen very carefully, Jeremy. They're going back and forth, and no one's giving the answer that's going to clarify it. So I'm trying to help clarify it. Brandon, we're talking about the water level, but you're saying, how do we know the water is level? You're introducing a second body of water.
Yeah.
What are you talking about?
We're measuring. We're using the water level above the surface of a still water, right?
Yes.
I'm just using the water level as sea level. Let's call it 0 sea level. If calling it water level is confusing. The surface of the water, and you're measuring the altitude above the surface of that water, and that's 3 feet. That's what your water level is measuring. So A and B are 3 feet above sea level, we'll call it. And you know that if you draw a line between those two, it is going to indeed be a straight line. How do you know along that whole 400 meters that it is 3 feet from that imaginary line to the surface of the water?
Water.
Wow.
I don't think
sea level. To sea level.
Here, you two. Watch out.
Surface of the water is sea level in this case.
Want to ask?
How can you think the water level
do you guys understand the question?
I do. Let me try.
I understand what he's saying. He's saying, how do you measure from the water level to the surface of the canal? Am I correct?
Yes, from the line. How do you know that line that you connect between the water level, so the end of the lines at A and B are each 3 feet above the water? How do you know that any point or every point along that line is also at 3 feet in altitude above the surface of the canal? Right.
You measure from the post you've put in and put the mark on to the surface of the canal.
Why are you guys not letting Bev?
At what point? Whichever point you want. You only want one at each end and one in the middle, don't you? That's all you need.
So now you've got 3 points. You've got A, B, and C.
You drive 3 stakes in, you put your water level on, you mark off where the water level is, and then measure down from that mark to the surface of the canal.
So in that case, you'd have 3 points, say, along the 400 meters. Bear with me here. A, B, and C are those 3 points. They're all 3 feet above the surface of the water in the canal, above sea level. You know you've got those 3 points that are 3 feet in altitude. How do you know in between points A and B and in between points B and C along that imaginary line that connects those? Every point along those lines is also 3 feet above the above sea level.
We've got 5 marking points, right? Because there's one at every 100 meters. 400 meters makes 5 marks. So if you're having A, B, C, well, you've got 5 points. So the ones in the middle of each of them are at the same level, right?
Yeah. So you've got 5 points that are at 3 feet now, say.
Yeah.
But Brandon,
so how do you know on yours? Hold on. How do you know on yours? You know? So you've got your 5 points. How do you know any segment between, say, A and B, B and C, C and D, etc., anywhere along those imaginary lines is also, every point along those imaginary lines are 3 feet in altitude as well?
Because you do geometry and you find a way to prove that 2 straight lines are sharing the same common segment, right? The same straight line.
Yeah.
Like, because that's the question, right?
Yeah.
You're asking us, is it curved?
Yeah.
Or is it straight?
No, I'm asking you how.
I'm telling you, yes, in geometry, there is a way to prove it is a straight line. Yes.
Okay, so in reality, if you're doing this test, how is it that you are going to say the segments from A to B and B to C, or even from D to E? How are you going to prove that those segments are all sharing the same plane, that they're all parallel with each other?
Because it's a straight line test, and there will be no rule of geometry in the middle.
No.
Right, it's not. We'll be able to prove it's not curved by showing it is straight.
I mean, but your test doesn't prove that it's straight all the way from A to E. That's the issue. That's what I'm asking you. Yes, well, if it does, then you haven't explained to me yet how you're accomplishing that.
Yeah, I've been on this show a couple of times, and you've done the same thing every time.
And I've never gotten a good answer.
No, because you don't let me go through it from the beginning.
I've let you go through from the beginning twice, but you should be able to answer this question pretty easily, because this is the key question into determining what the
water
shape
finds
of the Earth
its own level.
I know. I agree. Water finds its own level, guys. No one needs to tell me again that water finds its own level. I fucking understand 100% that water finds its own level, and I believe that the surface of water is horizontal. I'm trying to understand how this test conclusively proves that.
Okay, listen. Geometry. Just practical geometry, Brandon.
Geometry is not an answer. It's not a practical answer.
It is. Geometry
then tell me
where
how
we get
geometry proves
from.
it. Tell me how geometry does it.
That's what geometry does.
Explain to me how geometry does it.
It's, you guys are still not on the same frequency. Can I try,
Brandon,
please?
You don't understand what a proof is.
I do understand what a proof is, and you haven't given me a proof yet.
You just prove that the straight line is a shared segment, and then you prove that the straight line continues as a straight line.
And how do you do that?
Not a curved line.
With the rules of geometry.
What rule?
The axioms and the postulates.
Hold on, please let me answer his question.
The axioms and the postulates.
Explain it to me. It should be simple.
It's a logic. Listen, it's a logical inference.
Bev, bring up the
okay.
Bring up the bit of paper that has all the
No, you know how hard it is to go through this page, especially with an unwilling participant.
Okay,
I say unwilling participant, Bev.
I'm willing to have
because I think this is a very simple question to answer if you know the answer.
Okay,
just get to the punchline. Get to the
geometry,
fucking punchline for me and show me.
Two straight lines can't share the same segment. So if you've got two lines that are the same height, same elevation above the ground, they are the same straight line. They're not two different lines or, a curving line. This is why we're telling everybody to go back to the very beginning of geometry. Learn what a point is. Learn what a line is.
Only if all the line segments that you're talking about are parallel to the bottom line.
Please try.
And you haven't proved that the bottom is a line. You haven't proved that the bottom's a line. That's what we're trying to prove.
Bottom of what, Brandon?
Sorry?
The bottom of what?
Sea level. Sea level.
Straight line we've made.
The surface that you're measuring above with your water level.
Brandon, I can have a conversation with you that's peaceful. Can we please try? Please.
I am trying to get to a point I've been trying to get to for months.
I'm trying to help. I'm trying to help right now with a thought that I have in my mind. Can I have a conversation with Brandon, please? Okay. Let's say you drive a stake into the ground and you've got it marked off 3 feet high. Okay. So you've got a 5-foot stake. You drive 2 feet into the ground. You got 3 feet remaining. Now you walk 100 yards. You do the same thing. How do you know those two things are level? You know they're both 3 feet off the ground, but there could have been a deviation in the ground between you and them. You could be lower or higher. You don't know because of the distance. Okay? Do you follow that so far? Both your stakes are 3 feet high off the ground, but one of them is lower in elevation and you don't know it yet.
One of your stakes is lower in elevation. So you've got two stakes, A and B. One of you've marked what you think is the same height above the.
It's a 5-foot stake.
Okay.
You drive it 2 feet down. You only got 3 feet left. It's just straight up, right?
Gotcha.
Okay.
Gotcha.
Okay. Now you've got a graded field. You've graded the field as flat as you can get it because you're going to build a warehouse. Okay. And now you're marking off the corners of your foundation. So you got one foundation point, right? You got 1 point. You walk 100 yards away and you want to make sure that you have leveled your grade. So you drive that stake down and it's 3 feet high. But you know what? You didn't know that the ground topography dropped. But to you, you didn't know. So how are you going to check it? You get a water level. You put a water level at point A and you match it at the 3-foot line. And then you've got the other end of the water level 100 yards away. And lo and behold, it's not higher or lower than that point. Guess what you know now? It's a straight line. You don't have to do anything in the middle. Nothing.
It's always a straight line between two ends of a water level, Travis.
Yes.
That's not the question.
Please listen.
It is.
Okay, please listen.
That isn't the question, Bev.
If it's a straight line,
I'm not done yet.
Where's the curve?
Please, I'm not done yet. Okay, please listen. Hold on. Okay, now I'm going to change the result. Now point B is higher. So if you then put the water level at point B, it's not going to be level at point A. You now know that there's a higher elevation at point B. Now you've got a slope.
Yeah. Okay, so here, Travis, let me try to, because it's clear to me you don't understand what I'm asking, and maybe other people don't as well.
All right, that's fine.
All right.
Okay.
So in your little scenario there, we've got stakes A and B. Pound them 2 feet into the ground, and I'm going to assume that the ground from A to B is all the same altitude, right? So we'll call it 0. It's sea level between A and B.
If it's the ground, Brandon.
Sorry?
If you're talking about the ground, that's the elevation.
Thank you. Right? Thank you. Yeah, so it's all the same elevation.
You don't assume the elevation of anything. You have to measure it.
All right, here, let me finish my scenario here. So we've got stakes A and B, same elevation between the two. And the reason we know that is because the ground is standing water at sea level, okay? So we know that for sure, that it's the same elevation between A and B. We've got our stake sticking 3 feet off the ground. We take our water level, we put it at the top of stake A, put it at the top of stake B, mark two notches. We know those notches are at the same altitude above sea level, 3 feet. Now, if we connected a line, let's say we had some magical zero mass string, and we strung it from notch A to notch B. The question is, would every point along that line also be 3 feet in altitude above the surface of the water? That is the question.
Straight line.
We know that the no mass string that we strung is a straight line. We know that it's perfectly straight. Would the surface of the water be a straight line? In order for it to be the same altitude, our no mass string, the surface of that water would have to be a flat plane, right? A straight line.
Is the water, right, at a hydrostatic? Is it a like freestanding, just nothing acting upon it?
It's like the clearest day in all of history. There's not even like a butterfly farting anywhere. It's so flat. It's amazingly. It's horizontal in my opinion too, but that's what I'm asking. How does that test prove that it's horizontal?
By you use geometry and proofs to prove that it is a shared straight line segment.
How do you prove that it's a shared line segment?
By doing what and devising a method using water levels to show that. Or you could choose to show a method to show the absurdity of what the ball model would have to show, wouldn't you? You could use that reducto ad absurdum.
Okay.
Right, to show.
Brandon, and this is your 400. This is your 5 stake method that you're alluding to. Is that correct?
But that's one of them. Yeah.
Okay. Do you now? How does that 5 stake method prove that each of those segments is parallel and that every point, along that imaginary line that connects each of those are the same altitude above the surface?
Right. This is where you have to understand what a proof is. And
hey, Bev, I just wanted to help real quick, if I can.
Yeah, go on.
What is it you think I don't understand about a proof?
Well, I'm just trying to help out here real quick. Like the 100-meter water level, if you took an auto level in between and looked 50 meters each direction, you could check that horizontal. You can choose to do that or not.
The horizontal of the each segment?
Oh yeah. Yep.
But that would, okay, I'm not sure that would do it, because let's say I put my auto level in the middle of a segment A to B. It's 100 meters between them.
Yeah, you can go to the end too.
Yeah. I make it level, right? I make it level, right? Hold on. I make it level. I fire off my my auto level. Bam. It points to the same elevation, the same distance below on each one, on each stake. What does that tell me?
You could go in between. You could go before.
That means, right?
3-code planar points. Yep. You can look
to establish.
Let me say the problem and let me clarify it too. Okay, the problem is what they're saying. Okay, as frustrating as it is, the math lines up identical to the sphere if you're angling the each point. Okay, and that is very frustrating. But here's the solution.
Wait, let me give the fucking solution, guys. We know what you're doing. You're looking down.
No, you don't. No, you don't. Because you're making me look like an asshole unless you let me tell the solution. Okay, the solution is here's the solution is if you're going different distances with each shot, then you'd get a different fucking result. So it's got if we go 100 meters at a time over a mile,
50 meters.
Boy, it's killing y'all to let me fucking say my stance, right?
Yeah, can you let
Why won't you let me say my stance, dude?
I mean, what the fuck, man? Let him get it fucking out.
Here's the thing, okay? So here's how you judge that. You could do multiple different shots, which would be different angles by their math. So if you went 100 meters exactly at a time and come up with a mile, they could use angles against you and say that you're shooting around a curve. But if you went 100 meters one shot, then 150 meters a second shot, then 50 meters a shot after that, then if they didn't line up, they would line up different on a spear, okay? That's the only way to distinguish is if you use different distances, which they do in surveying. They don't use the same distance shots. So to me, planar surveying proves flat water. That's my point.
Why you would come and defend the globe? That does not make any sense to me whatsoever.
I'm not defending the globe. I'm telling you how to distinguish. You didn't hear nothing I just said because you didn't listen.
I can't interrupt you because you interrupted me. Okay. What I was trying to explain.
You said I'm defending the fucking globe, dude. Apparently, you didn't hear me.
No wonder you won't ever come talk to us.
Yeah. Why did you say that, Cleary? He wasn't defending the globe. He was describing the situation. I don't know what the fuck you're talking about. Why'd you say that?
If you His first words were the globe.
Yeah. So what? That doesn't mean he's defending the globe?
He's saying that the measurements are going to be equal with the globe math. And
the math.
Yeah. He's not saying that it's the Earth is a fucking globe. Why would you say he's defending the globe?
Their math, geometry, curves.
See, I don't.
Exactly. That's what we're trying to prove, that it doesn't.
Anyway,
but why y'all so triggered? All I was saying is you could take a
why are you and
I'm triggered because you said I'm defending the fucking globe, dickhead.
Damn, dude.
All right, guys.
All right, guys. Down. Let's all settle down, myself included. Let's all calm down.
Yeah, that's a good idea.
That's
take
ridiculous.
a deep breath, guys.
All I said was get 50 meters to the center of the 100-meter water level. Look front side, back side. Move to the end of the water level. Look back and look forward again. You're connecting all those line segments by doing that, and you have one straight horizontal line.
So you're going to do it optically? Is that right, Clear? You're going to optically look down?
What do you define as optics? Would you say that surveyors are accurate in their techniques when they're doing differential leveling? Now you're going to
answer my question with a question?
I'm answering you. It is accurate because surveyors use this tool to use in differential leveling to determine elevation changes. Even though you actually physically have to look with your eye, it's not like long-range photography over the ocean. Okay, it's not the same thing.
Yeah, but it is optical. You're still making an optical measurement.
Can I ask a question?
When you use it within its limits, it's very, very accurate.
Okay,
thank you.
So 400 meters is within the limits. That's what we're saying.
You're not looking 400 meters. You're looking 50.
That's a water level 400 meters, isn't it?
Can I ask a question?
So what are we looking at 50 meter? Are we looking at one segment? Is that what you're talking about?
All right, hang on, real quick. Maybe you don't get it. We got 4 football fields to go. We go out to the 50-yard line. 50-yard line. We look back, okay? And then we look forward, all right? Then we go to the end of that first football field, and we look back, and we look forward, okay? Then we go to the next 50-yard line on the second football field, and we look back, and we look forward, right? All the way down. 50% overlap.
50% overlap. So you're looking past the ones that are the post that's behind you and the post in front of you to the one beyond it. Is that what you're doing?
Yes.
Okay.
Yes,
so you're leapfrogging when you're looking back.
Doing.
Yep.
Yeah. That's exactly what I was saying, dude. Use different distances. That's exactly what I was trying to say, man.
Right? Yeah, but what we're doing is we're going to substitute that looking for an actual water level, like a real physical water level, an actual thing, right? With the water that evens out at every point. Now, every 100 meters.
Okay. Wait, you're not gonna do what Cleary described, Beth?
We've already checked that 100 meter water level is level. We've already done that. That's been done ages ago.
You can do both and check the results against each other.
Wait. Okay.
Which they'll all be the same anyway.
100 meters, there's not very much difference between the two models, right? It's level. I believe you that it's level. Totally.
Yep.
So how did you determine that 100 meters was level? Real quick.
We got a water level, and we put an auto level in the middle of it, right, and looked at either end. Then we moved the auto level to one end, and we looked at both ends again. And then we moved it 50 meters past the end, and then we looked at both of the ends again through the scope. Right? Is that enough?
I don't know. I don't know.
Because it was enough. It was enough for me to prove that a water level was level, but I already knew it was level anyway.
You keep extending the line and rechecking on what you've done.
That was my point, man. If you use different distances, then if it was a sphere and you use different distances, you would get varying results. You'd get varying results, but you don't in real life. You don't get varying results.
Yeah.
That's my whole point.
Doesn't matter ever. Nobody. If you're doing differential leveling and you're just concerned with the elevation, you do not matter about the distance you take.
Right. That's my point. That's the only way to distinguish. Doing it mathematically, that's what I was trying to tell Brandon, is doing different distances, you'd get different results on a globe, but in reality, we don't get different distances.
Yeah.
That's what I was saying, Brian.
I agree.
We're not on a globe, so why talk about
I don't think these guys are trying to falsify one or the other models. Brian, I think we have different goals, and that's why I get frustrated. But that's okay.
We're all on the same team for
Brandon. Let's wrap this up. I do have a question for Bev. Bev, are you attempting in any way to falsify one or the other model and prove or disprove the shape of the Earth, the shape of the surface of the Earth?
I am here personally because somebody challenged me, right, to prove something that I already knew that it was the truth, right? So what I'm doing here is proving to myself that level is horizontal. Now, over the 2 years I've been doing this, a lot of people have gotten butthurt. A lot of people have called me a flat earther. They've even gone as far as to say, because I say that level is horizontal, then I am a flat earther, right? The very person that called me a child abuser is the same person that says, if you think level is horizontal, then you are a flat earther, right? So I'm doing this for everyone that gets called to be a flat earther, right? But I'm doing it for myself, just proving that level is horizontal. That's it.
I agree with Bev. I'd like to give final thoughts.
Hold on a minute. Let me try it a different way. Will your test prove what the shape of the surface of the Earth is?
Right. Proof is a personal thing. You have to go through a process to earn your own proof. I cannot give it to you, obviously, because you don't seem to understand
geometrical
the
proofs.
geometry.
No, shut the fuck up, Bev. With this, you don't seem to understand, and these sly little fucking insults you keep throwing in.
No,
it's not. Are you trying to trigger me,
Brandon? No, Brandon. No. A lot of people do get triggered by me, though.
Let me get my final thoughts real quick, man, to cool things down.
One more thing. You didn't answer either of my questions. Are you trying to prove the shape of the surface of the Earth? Will your test prove? It sounded like no and no.
It's like I am doing it to prove to myself that level is horizontal.
And if level is horizontal, the Earth is fucking flat, Bev.
Okay, then. Brilliant.
So you are doing it to prove the shape of the surface of the Earth.
Well done, Brandon.
Okay, thank you. So that is a yes then. You will prove the shape of the surface of the Earth.
To measure elevation, right? Which disproves flatness.
Oh, for fuck's sake. All right, I'm done. Go ahead, guys.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.